Today's lesson is about using trig ratios in a very special triangle, which is a right triangle. Remember, in a right triangle, one of the angles is 90 degrees. So whatever we are going to talk about in this lesson is going to work only in a right triangle, 90 degrees angle. Before we continue, just to remind you that trigonometry means measurement of a triangle. This is the name in math which is assigned to the process of measuring the sides and angles in a triangle. Now, the primary trig ratios that we are going to talk about are sine, cosine, and tangent. Remind you from grade 10, 11 that the sine, cos, and tan are defined in a right triangle. Again, a triangle which has a 90 degrees angle, which is represented with a square or sometimes the number 90, as sine of A is defined as length of the side opposite to the angle divided by length of hypotenuse. Now, just to remind you that the hypotenuse in any right triangle is the side which is in front of the 90 degrees angle. So the side which is in front of the 90 degrees, we call it hypotenuse. This is the longest side in a right triangle. The other two sides are called the legs. Now, with regard to any angle, there are two sides which are important here. Let's look at angle B. This side is called adjacent, and this side is called opposite. Now, if you look at angle A, this side is going to be opposite and this side is going to be adjacent. So adjacent and opposite, they change depending on the angle. For the 90 degrees angle, we do not talk about opposite or adjacent. The only thing that we are concerned with angle 90 is the hypotenuse which is in front of it. Now, we define sine A, as we said before, is the length of the side which is opposite to the angle divided by the length of hypotenuse. In this example, angle A, the side in front of it, is this side which has this length of A, and the hypotenuse is length of C, so it's A over C. The cosine of angle A is length of adjacent to angle A. Adjacent to angle A is side B, divided by the length of hypotenuse, which is C. And the tangent of angle A is length of opposite to angle A, which is A, divided by length of the side which is adjacent to angle A, which is B, so A over B. Now, if you remember from grade 9, to memorize these three ratios, we use the acronym SOHCAHTOA. Now, SO, S-O-H, represents the first character of sine, which is S, then opposite, which is O, and H, which is hypotenuse. So Ka is cos, adjacent A, hypotenuse H, and Toa means tan T, opposite and adjacent. So memorizing this acronym, you can use it to write down the equations for each trig ratio, sine, cos, or tan. Again, these are just refreshing your memory from grade 10 and 11. There is nothing new here. Remember that we can only use trig ratios, sine, cos, tan, in right triangles, and we can use it to solve triangles. Just to remind you, solving a triangle means finding all the sides and all the interior angles of the triangle. This is what solving triangle means. So let's do a couple of examples here. The first one is that we have to find length of side P here, which is this one. By looking at this triangle, since this angle is represented with a square, we know this is 90 degrees, so we can use the trig ratios. The question is that which trig ratios is the best here? The easiest way to do that is to look at the given information and decide which trig ratio can be used here. We know the angle, we know the side in front of it, we are looking for the side in front of it, and we know the hypotenuse. So we know angle, opposite, hypotenuse. And this one is represented with sine. So I can write sine 60 is equal to opposite. Opposite is P, which is unknown, divided by hypotenuse, 225. We know that any number can be written as the number divided by 1. Looking at these equivalent ratios, I can use crisscross or cross multiplication, and I can multiply these two and these two, and then solve the equation for P. So I can say P times 1 is P is equal to 225 sine 60. Using your calculator, making sure that the mode is set to degrees. If you evaluate this expression, you will find that P is about 194.86 feet. Let's do the next example. Before we do that, let's talk about inverse trig functions. There are cases that the sides are given and the unknowns are the angle. Instead of using sine, cos, tan, we can use the inverse of these functions. What these functions return, they return the angle. For instance, for this triangle, if I find the inverse of sine of any angle is going to be the same angle. How do you find the inverse of an angle using your calculator? Is usually there is a second function key on your calculator, and above the sine, cos, tan buttons, you usually see sine -1, cos -1, and tan -1 functions, which you can use to find the angle when the sides are given. So remember, you use these functions if you have to find the angle, not the sides. Let's see what exactly example 2 talks about. You have Michel, which is drawing a map of a triangular plot of land, which is shown here. We are supposed to find the angles in a triangle. First of all, again, this angle is represented with a square, so we know it's a right triangle. Let's try to find angle B. Again, there are 3 trig ratios, sine, cos, and tan. Let's see which trig ratio we have to use. I have to find this angle. So angle, I know the length of the side opposite to it. So angle, opposite, and I know the side adjacent to it. So angle, opposite, adjacent. If you go back to the trig ratios, you can see that the tan is the one which is a good candidate for this case. So I can write tan B is equal to 1.2, which is opposite, divided by adjacent 1.8. Now, to find angle B, I'm going to use the inverse function. If you use second function tan on your calculator, you will find that angle B is about 33.7 degrees. To find angle A, there are two ways I can do it. I can use either a trig ratio again, or I can use the identity that the sum of the angles inside the triangle is always 180. We know one angle, this one is 90, so the sum of angle A and B has to be 90 degrees. So I can say angle A plus angle B, 33.7, is 90, or angle A is 90 minus 33.7, which is about 56.3 degrees. Now, part B says determine the bearing of the third side of the plot AB, i.e. angle BAC. Just to remind you, the way that you read the angles, it says BAC. You start from B, you go up, and then it says A, and then it says, oh, there is a mistake here. This angle is BAN. So you start from B, you go up to A, and then you go toward N. So we are talking about this angle. To find this angle, I use the fact that the straight angle is 180. So I can say BAN plus angle A, I found angle A is 56.3, is 180. So I can say BAN is 180 minus 56.3, which is about 123.7 degrees. Now we are going to talk about two very, very important definitions in trig. One is the angle of elevation, and the other one is the angle of depression. Both angles, they concern with the horizontal line from the eyesight. Angle of elevation is always toward top, and angle of depression is toward the bottom. When you are looking at something which is over your head, like in this case, this is called angle of elevation. Like elevator, it goes up. Angle of depression is when you look at something which is below line of sight. This is called angle of depression. Angle of elevation is this angle, angle of depression is this angle. Now we are going to do one example using angle of depression and elevation. You have a helicopter which is flying horizontally and at an altitude of 1500 feet. So we know that this distance here, from here to here, which is the same as this, is 1500 feet. The angle of depression, remember the angle of depression we said if you look at something which is below your eyesight. This is the horizontal line, which is your eyesight, and this angle is angle of depression, is 9 degrees. How much further must the helicopter fly before it's above the island? Meaning I have to find this distance. Let's call this distance x. Now this angle as it's shown with the square, so it means it's 90, so I can use trig ratios. Now which trig ratio to use? Again, we have the angle here, we have the opposite, and we are looking for adjacent. So angle, opposite, adjacent is tan. So I'm going to write tan 9 is 1500 over x, opposite over adjacent. Now again, this one can be written as a fraction. In this equivalent ratio, I'm going to use cross multiplication, so I'm going to say x times tan 9 is equal to 1500 times 1. Then I'm going to divide by tan 9, and I'm going to find x is approximately 9470.63 feet.